Here's a tool I bet you've never seen before. It's got a handle, it's plugged into electricity. It's called a hot knife. This is actually used to cut SIPS panels. I'm coming to you from Phoenix, Arizona. We're visiting my builder buddy, AFT Construction, where they have a super cool, crazy efficient house here in the desert under construction. And the whole roof on the house is SIPS panels like this, 12-inch thick, OSB on both sides. They come pre-cut, so most of the panels like this, where they join, have a spline that comes together. But if you ever had to make a field modification, the manufacturer sends this tool. Let me show you how it works. This heats up. You can see a little bit of smoke coming off it right now. And all you do is press it. Now you see the width right here? This is sized perfectly for the width of this panel. Hey! Wow, didn't expect the flames. And we could cut down and then pull out. And there we go. That's how we could cut in, let's say, a spline for a 2x10 if some of these panels were coming together, if we had a reason to do that. What a cool little thing. Now we've got a really cool project to show you in the build show today. We're talking SIPS panels, ready frame, thermal breaks everywhere, triple glazing. This is a really cool net zero house. We're gonna have a lot of fun today from Phoenix, Arizona, visiting AFT Construction. Let's get going. Brad, so good to see you, man.
Good to see you too.
What a gorgeous house,
Thanks.
dude.
Glad to have you.
I love this modern architecture, flat roof. It kind of hides in the mountainside here with these saguaros in the background of the mountains. This is pretty nice.
Well, come on in. We got to show you around.
All right, Brad. So, I mean, before I even walk in, I'm already seeing details. We'll come back to this. But look at these ICF walls. It looks like you might even have a SIPS roof going on here. This looks like a really cool house.
Yeah, so what's interesting, I mean, as you know, we're huge fans of architecture. We love building, and this is one of those perfect jobs where you have modern architecture that meets building science, right? And we've done ICF. You've been out here filming our ICF before.
We did an ICF video with you like 2 years ago now.
Yeah, and now we have one that actually has a ton of glass, triple pane glass. It has these amazing details, and now the building science side.
I love it. So gorgeous modern architecture, but how do we do that and still be super efficient?
Well, that's the hard part, right? So it's really a lot of coordination, and thankfully we have a mutual friend, Mark LaLiberte, who's our client, who's really involved with the building science side, and he's also trained some of my team, which has been awesome. But working with the architect to understand where's solstice, where's the sun, right? How does that sunlight come into the house? How can we design overhangs?
Yep.
How can we have natural light into the house so that you don't have just a house that's completely closed, a vampire house. You have something that's wide open with a ton of natural light.
That's right. Now talk to me about, let's start with ICF. I mean, you've got so much to talk about in this house. This is an example of what you used here, I'm assuming, right?
Yeah, so you can see here, I mean, we have the ICF walls, and these are, we worked with Fox blocks, you know, They worked with us on these. And you can see here that where they have the logo, these are actually where the brackets are, right?
So there's basically like a stud in the wall there.
Essentially a stud. And what that does is that allows us on most walls of the house, we'll install the drywall straight to the face of the ICF on the interior.
Got it.
Now we do have a hot knife, which I know on the intro there you showed with the SIPs. Similar, we have a knife that actually cores out for electrical and any wiring we have to do in the wall.
Okay.
So in that way the drywall goes flush to this styrofoam.
But where you core that out, you've got an interior insulation and you've got an exterior insulation. So even if you cored out a pretty good section of this,
it's very minimal. Still have that R value.
A ton of insulation.
Yeah, and what's interesting is typically with these interior walls with the concrete, the foam on either side, you're typically getting about an R20.
Okay.
But now we're doing these energy sticks, and these energy sticks bring this almost up to an R30 on the exterior wall.
What is that? I've never heard of that
Yeah,
before.
so this is actually specifically designed. You can see here how it's built. And what happens is, on most ICF, when I toured you through our last ICF build, you have the Fox block styrofoam, and this all gets filled with rebar and concrete, right?
And this is like polypropylene or something, and these chairs fit perfectly, so your rebar
sits right in there, and it just runs through, and that gives it that structural integrity because it is bearing a lot. As we get through other parts of the home, we'll show you that.
Yep.
But the energy stick is really key because now as we get into the amount of glass and the modern architecture, that sun, look, it's nice right now. We're here in April, it's beautiful. But come July, August, that sun here in the south is beating on this house. And on the west, late in the afternoon,
it's over 100 in the summertime.
Oh, yeah.
Right?
I mean, up here, in most of Scottsdale and Phoenix, they can get to 115, 118. It's a couple degrees cooler up here because we're in Cave Creek. But the energy stick, These come in every cavity. So now these slide right in, as you can see, nice and tight.
Check that out.
So now what happens is on the exterior wall, we're double layer foam.
Okay, so this is the outside, this is the inside. Now instead of just this R10 here, you've got
Almost an
another
R20,
R10.
yeah.
So you've got R20 outside of the concrete. The other thing I like about this is it reduces the amount of concrete.
Exactly.
Because you're
So
not
cost,
necessarily
waste.
in an earthquake zone here or a hurricane zone where you might need that thicker concrete. It's going to reduce the cost and give you better insulation on the outside where it needs to be.
That's a super good point. I'm glad you brought that up, Matt, because you think about just sustainability of concrete. It's a very expensive product, and to save on that cost, and it still gives you the same structural integrity as you mentioned, but saves a little bit in the pocketbook and makes the house more efficient.
That's really smart. I like that. Now, I've not done an ICF house myself. Pardon me, I haven't done a Fox Block ICF. I'm seeing a little bit of foam in some places, and then I'm also seeing wood where you've got windows and doors. Talk me through both of those.
Yeah, so really what happens is, I mean, like the LVLs here, I mean, especially for anywhere where we have jams, right? So where we have, so we're running transoms through here, our door bucks, window bucks. This gives us a nice, substrate backing to install all the windows. And these are triple pane Benelli windows, which is the luxury line from Pella. And so they, working with them, this is just great. It's a great termination point for the ICF and concrete, and now allows
triple pane windows in the desert. I love it.
In fact, it's pretty neat here in the fixed window in the entry. They're doing a 760-pound fixed window. So largest fixed triple pane window that Cardinal Glass, who's actually the glass manufacturer, has ever made. So
and I heard the numbers before I came. You and I were talking. You're something like a U factor of around 0.12.
0.12, yeah, for most of the glazing in the house.
Which means your glazing is a little over an R8.
Right.
Which is about the same as a normally insulated 2x4 wall. So even though you've got a lot of glass, you've got really smart overhangs to keep the sun off the glass from the south and west. And you've got really good glass to begin with a good solar heat gain coefficient and an R8 triple glaze. That's pretty impressive.
And that's something even for me, and I'll just be open, when we were going through the design element and thinking of the building science to modern architecture, because there's a lot of glass. You'll see this as we get to the great room. It was really hard to comprehend that a 2x4 16-inch on center insulated wall is similar to the triple pane glass, right?
That's amazing.
But then you get the value of the natural light. And as you mentioned, I mean, just the way the architecture, and this is where architecture has come so far and why it's really fun with our clients, is that when you understand where the sun's at, especially depending on the aperture, time of year, these overhangs, when that sun is really far south in the summer, it's going to protect us, and then the sun comes more north, right? In the winter, we still get the natural light, but we're not losing that heat gain. So
that's really smart.
Yeah.
Back to the bucks real quick. I love that these are LVLs because I've seen pressure treated bucks before that warped or moved or changed.
Right.
And these are going to be really structurally sound. But I do worry that maybe you've got some ground moisture coming up and getting these wet over time. Have you thought about that as well in this project?
Yeah, that's a good question. And so that actually has to do with the slab that we did. So we have an insulated slab here.
This is an insulated slab?
Yeah,
Wow,
the entire house. And so this has been pretty fun because, again, working with Mark, this is the first insulated slab that we've done.
Cool.
And so this has, our normal, as we prep the slab, we have 3 inches of rigid foam.
Okay.
And then we have, all the seams are taped, and we have the membrane, and then we have the stego mat.
But this is a stem wall, not a slab on grade, right? So
No,
this
slab on grade here, but we do have stem walls. So we still have the exterior stem walls, but then we have...
So the structure is bearing on the Fox blocks.
Correct.
And which is down onto a footing below grade.
Yep, footing below grade with the stem wall for exterior walls, and then slab on grade.
And then this slab right here has foam underneath it.
Foam underneath. So we have the entire house has foam from SIPs to foundation to exterior walls and energy sticks. So the whole thing essentially has that full barrier.
And then what's on top of the foam before you pour the concrete?
So we have a stego mat. So we have a stego mat on top of the foam. And of course we do our termite pre-treat because we have subterranean termites in Arizona. And then we pour that slab.
Got it. And so that stego then is going to keep any of that ground moisture
from coming up through the slab and wicking up into here.
And keeping this nice and dry.
Right, which is a key component. And it's interesting because anytime we do this, as you know, as a builder, there's a lot of education for all of us, right? As we're working through this. And one of the concerns from our concrete company was, hey, there's going to be a ton of cracks. If you're doing the rigid foam, we have foam slab. And even like Mark, who our client, he said, no, it's not going to happen. As you walk through this house, you'll see it's at minimal, if any. I mean, you can see right here. I mean,
I don't see any cracks at all.
No, it's great. There's no
gorgeous.
cracks. Yeah, it's turned out really well.
Really nice. It's interesting, these studs, or the polypropylene studs, Looks like they're on 8-inch on centers. Is that right?
Yeah, they are. And so these, again, this is perfect for drywall because, as these lay out, just more spacing. Depending on what we install here, especially in a modern home, you may have floating cabinetry. So in that case, we'll come through and we'll trim some, knife out some of the foam, put some LVLs or some backing in here. So then you have that extra support.
Gotcha.
So it just gives more meat in there as we're putting any backing or MDF, whatever it may be that we're using as a substrate for, depending on the weight, if it's a heavy mirror, artwork, cabinetry, which is sometimes installed.
Very
or bath
cool.
accessories, right? I mean,
yeah,
aging
you're
in
gonna have
place.
to put something on there.
Yeah.
I see why you like it here in Phoenix. This is gorgeous. Hey, there he is.
Hey, buddy, how you doing?
Mark, how you doing, brother?
Good to see you.
This is quite a house, Mark, I've got to say.
Really?
Quite a property. I mean, these mountain views, the cactuses. Now, I gotta be honest though, when I think of you, I think of the guru of efficiency. You've taught me so much over the last 20 years on how to build a durable house, an efficient house, a smart house. I don't normally think of glass houses in the desert as being particularly efficient or smart. Talk to me through your reasoning and what you did here.
Yeah, it's a great question because, when you think about the desert, everybody builds these houses with small windows, but the views are spectacular. And so what we had to do is make a balance between extreme thermal efficiency on the enclosure. That's what it's always about. You do such a phenomenal job of that. But to get with glass and take advantage of the views, we went with Cardinal Glass. And Cardinal Glass created a triple glazed window with a U value between 0.12 and 0.14. So what that gives us is the performance of approaching a 2x4 wall, but still a visual bridge to the outside that really makes living in the desert so fun, right? And coming from Minnesota, we're always hunkered down in the wintertime. You come out here and you're like, oh, this is amazing until July, right? And then the whole thing changes. It's like a complete opposite. So living in the desert's a whole different process. And so I really love living here, but you have to get the same characteristics of thermal performance that we're used to in the cold, which is what you've done so much in Texas. We always over-insulated here. Here it's 2x4 walls still. And we've got to really change the way we look at thermal enclosures any place you build. And the better the enclosure is, everything else works so much better.
Now, you've done more than just windows, though. For instance, on this north side of the house, I see a lot of clear story windows. But on the south side of the house, we're already here at 9 a.m. We've got a lot of sun coming in. What have you done to mitigate this?
Great question, and what we wanted to do on the south side is still take the benefit of, wintertime is cooler up here. We're at about 3,600 feet elevation. So we wanted some solar gain in the winter, but to block it in the summer. So there's a louvered shade system that'll go out and it'll extend out almost 6 feet. So in the wintertime, we'll have them open and let some sunlight in. In the summertime, we'll close those up. As the angle gets so steep, one of the benefits of the sun is that, the solstice really in the springtime, it stays low. I like that. And then when that sun comes up, it's over 70 plus degrees in scope. So now that overhang really helps protect the windows. So these will be still beautiful view, but blocking the sun. I'll never get sun on those windows, which, like you said, is the reason for putting the clear stories for one more layer of glass.
It's really smart. And so instead of doing, let's say, an exterior shade where you would have nothing coming through, you just did that variable blockage of the sun via a movable awning. When we drove in, I noticed that there's this house on the hill that looks like also a pretty glass house, pretty modern. All their shades are down and all their windows are facing south. So now they've got no view, whereas your house here, Brad and Mark, we're talking about all these 360 views, and this is your kitchen, living room. I suspect you'll spend a lot of time here. The pool's out this door. You're really catching that. Now, in Texas, I always say the fight's in the roof. The Texans wear a good hat, a good sombrero to keep the sun off us. What have you done for that July, summertime sun?
Yeah, it's a great question. Oftentimes we see the roof systems here have kind of low pitch, really close to the eaves. The attic heats up a lot, and they still put the ductwork up there. Ooh. And so what we tried to do here is create a truss space for all the mechanical runs. Then above that, we installed a SIPS panel. And this has been around for 40 years, SIPS has. But the idea here was that we really wanted to create a whole system that sat down and was a complete thermal break above that. So the TPO will be above that for water protection, but there's really almost no gain back to space.
So you're telling me this foam piece, which is what, 10, 12?
This is 12 inches from
12 inches
edge to
wide.
edge. Yep.
This is on top of these trusses here, all the way continuous?
On the entire house, the whole trusses were, the old SIPS panels were dropped on top and screwed into the trusses.
Dang.
So we used timber lock screws, which are about 14 inches long, and they drove those through. So this ends up being both the structural part of the roof, it is structural, provides some overhangs, that also supplies a remarkable thermal break for everything.
Yeah, our 40, 50? What is this?
It's about 48 basically for
Almost
the
50.
Almost 50. So I get 50 roof. You've got a 15 slab. You've got triple glazed windows on the walls. We'll have, of course, an airtight building.
Yep.
And all of those pieces together should give us the enclosure we're looking for. So as you get to approaching net zero, the idea that we talk about, it's as close as we could get and still get the advantage of the views.
Okay, so you are going to put solar on this house
We
as
have.
well to get to that actual net zero. How much solar do you need on this house?
Well, we're probably going to put about 10K. And
not
that
bad
shouldn't
at
be
all.
too bad at all. We'll put that on the garage roof. It's been beefed up a little bit to take those. And then because the angle is so slight, you won't even be able to see those. You drive up, the parapet should shade the solar
That's pretty
panels.
cool. So 10 kW, and then you'll have a house that will basically be a zero energy bill at the end of the year.
Yeah, and that's the goal. I think in terms of two people living in a house, there's always a challenge as to what net zero represents. And then with the pool, it makes it extra difficult.
Yeah, the pool's harder.
The pools are hard. But I think the idea is just to get that low energy load. We know that over the period of time, we're going to watch energy prices go up. It just has to.
Yeah, I mean, look at it right now.
And it's going to get worse. We can't build more power plants to take the growth rate. And also in Arizona, our concern is Phoenix grows by 300 people a day.
Shoo.
So try to imagine trying to build infrastructure to compensate for that. So as that gets challenging, I want to make sure that I'm never worried about having a cold beer.
For sure. All right, before we leave this section, I want to look at a detail over here, but what is this? What is this little piece of roof that we're seeing here?
Yeah, it's so cool. You look at the SIPS panels come in there 8 feet wide and 24 feet long. So when they
8 by 24 these panels are?
the panels are 8 feet wide
Holy
and 24
cow.
feet long. They come on a great big semi and they're lifted by a crane. And so that as they move the panels together, 8 feet wide is the biggest they can make the panel. And so then when they do that, blend them together, they're going to take this spline, which is just short of the OSB thickness, right? The next one comes in place. So this is all glued, and then they'll attach the nails here.
It's
and
like
then,
a double
Like
tongue.
TNG.
Yeah, like a tongue and groove.
it's like a tongue and
And
groove.
so then they glue this and screw it, and now we've got a structural joint that's also not a thermal bridge. Because if
Correct.
you'd used a 2x12 in here,
I'd have
you'd also
continu-
get the structure, but you'd have that loss of energy at each one of those.
Correct.
That's pretty cool.
Yeah, and the only place we try to put any wood is if we're mounting against something or needing something a little more beefy, maybe holding a post, but there's so few of those. It's kind of this monolithic layer of R50 just sitting on the roof, and it really,
that's
in this
cool.
climate, works.
That's awesome. Now, Mark, you got to talk me through this. This is a detail that you do not see very often. That is this looks like 3-inch or so piece of gray foam that sits between your exterior door and your slab on the inside.
Yeah,
How the heck did you do that?
Yeah, that's a great question. I don't think you'll ever see it again. But what happened is the ICFs came all the way up and they stopped just short in terms of height and left some rebar exposed. The idea is that we're going to put a big threshold for a sliding door. It's about 14 inches wide.
Okay, so this whole space here is threshold, and that's
Yes.
why you've got this curb here, Brad.
Yep, that's to help water from getting out. But what we were worried about is in Arizona, on the southern exposure sides, especially in west, the sun just bakes here, and the heat just transfers to the inside, and it's almost impossible to cure that. It's really difficult to insulate on the outside because of damage and insects getting into that. So what we did is we engineered a different strategy. This is a 40 PSI extruded polystyrene that was placed right at the SIPS, the ICF interface, and then we had rebar sticking up. So when we did a second pour, we put the frame out here for the poured against this after the slab. So now I've got a thermal break. The threshold will sit there, and
So then this went in before you poured this slab, I guess, huh, Brad?
this went
Yeah.
first. Then we did this, and then we
Right.
poured this
Yeah.
second.
Okay, gotcha. And now at that, basically in line with that triple glazing, you've got this nice thermal break there. So there's really very few thermal bridges in the entire house.
Yeah, and as you mentioned earlier, looking at this climate, even cold the same way, thermal breaks and thermal bridges are so difficult for us to catch. And so we're always trying to avoid those at all costs. We're putting foam on the outside, furring strips. Those are always to interrupt those thermal break issues, and this really helps to do that in a kind of a unique way. I hope it works.
I'd say so. Man, what a cool house. Guys, I can't come to the desert without getting up on the roof. How about we go up on the roof and see what those views look like?
Sounds great.
All right, we'll meet you up there. Gentlemen, this view, I mean, 360 degrees up here is gorgeous in every direction. I love it.
Yeah,
How much rain do y'all get in this part of the world, Brad?
So it's interesting. We only get about 6 inches. I mean, it's not a whole lot. Occasionally you may get 8 up here because we're a little farther north. Funnily enough, we got a little snow this year, which is kind of odd for us. But one thing you'll see is you can see this is a little bit more of a flat roof. A lot of times in Arizona, we have modern architecture with the flat roof, so it's not a conditioned space with high pitch like you may see in other parts of the country. But with that comes concern because we have clients, you know, with the flat roof, with architects wanting integrated gutter systems, which, you know, we're trying to prevent water. So it's great to have Mark on here walking through how we want to do this design.
Yeah.
And Mark, you're from the north originally. I know you grew up in Minnesota. What do you think about these flat roofs as a guy who originally is used to pitched everywhere and much higher rainfalls?
Yeah, it's such a great question because I always said I'll never do a flat roof because I knew that it's a horrible idea to not pitch it and get the water away. So in the architectural design, they were like, a flat roof's going to look much better. I wanted flat interior ceilings. So I said, all right, we'll go flat. And you know, the challenge with flat roofs is also that trying to find a way to scupper the water, and what Brad said was true. They wanted to do internal gutters, and I couldn't think of a bigger nightmare than doing that. So one of the challenges with this was that in hindsight, which is always 2020.
For sure.
I would have put a slope on the trusses. So I would have intentionally got my slope, but what I did is I have a flat truss with a SIPS panel on top. So now we had to build crickets on top of all of that, and then plan for the direction. Now we're sitting on the cricketed roof.
So there's a little bit of airspace underneath my feet.
A little bit of airspace
because you've got pitched framing, some 2x that are ripped, and then this top layer of plywood.
Exactly right. And we'll put a TPO on top of this. But this was probably an additional expense I would have avoided. But it'll work out great at the end. But in hindsight, it really is smart to take a look at from the very beginning, plan for things like rain way farther down, and I should have done a better job of that. Even with 6 or 8 inches of rain, it's enough.
And it's interesting that well, 2 things I want to mention. Like on your garage, you did a pitched truss. So when you order your trusses from Builders First Source, they can do pretty much whatever in truss engineering. They're amazing. So you pitch those, but these were more flat. And in hindsight, you could have made a truss that had flat ceilings, but had a pitch on the top so that your SIPS panels are normal 12-inch thick SIPS panels. And I suspect that this roof actually craned down pretty quick, didn't it, Brad?
It was super fast, yeah. I mean, you can see we had all the SIPS panels, and it was quick. I mean, they were out here at the equipment and set these in no time, so.
It's a big panel. It was 8 feet wide and 24 feet long. So they had 2 mounts on it, and the crane would pick them up in a single point. They would just crane them in place. Each one of them was numbered, and they just slid them right in. So the splines fit into place, and they locked them all down. Timber lock screws, 14 to 16 inches long, into the truss, done.
That's amazing. So that gun that I showed at the beginning, that was the foam melter gun, you really didn't need to use that, did you? Because all those cutouts were already in place ahead of time, right?
Yeah, the company was called Extreme Panel Technologies, and what they did is they have a Hunzinger, and they pre-cut everything. Every panel fit perfectly. So in the early days, SIPS would get set down and they had to custom everything in the field. But when they came out, every groove, every window opening was already pre-done. So the only time they had to cut the foam out was for the ledger. So when they put the ledger on the ICF, they had to slide that SIP panel on, and they didn't quite know the depth of that beam. But other than that, it was almost no cutting at all.
Yeah, so it's pretty rare. It's not like you're using that on every panel. Very rarely would you use that. Right. The last thing I want to mention, Mark, I love that you're both you know, an experienced building science guy, but you also have a really refined sense of architecture. The architecture is gorgeous here. What are you going to do without internal gutters? Is this simply going to be a box gutter on the outside?
Yeah, it'll end up being a box gutter. We're going to watch and see how the water behaves and where we see it flow the most, and then we'll look at pulling gutters if we need to. We also, up here in the desert, sometimes you think about harvesting rainwater, right? Mm-hmm. So there's enough area down there to put a tank and store water, should that get a little more challenging. So we'll see what happens afterward. It's one of those silly things. You go, let's wait till it rains and see what it does. And that's one of those.
So building science versus architecture, and in this case, the building science won.
Yeah, I think it's a balance between giving into some of the architecture and trying to make it work with building science. Is always an interesting angle.
That's right, and I think that's why Brad and his team were such a great fit. They're used to doing super detailed, expensive, modern, cool projects, but they also have that building science background like you, so they can go with you and your architect, hey, why don't we consider this? This will also look good, but it's going to give us what we want in terms of building performance, longevity, durability, that kind of stuff.
Yeah, I don't think we could have pulled this off without AFT, because anybody else would have said, I'm a little overwhelmed with all the details, and they just continued saying, let's do it, let's work on it. We'd have meetings with the trades. Everybody was on the same page. They'd show up and know what to do. And that's a sign of a pro. It's like what you do. You gotta have communication as a fundamental, and building science sounds so scary, but in the end, it's really fundamental.
It's just smart building. Now that we've seen this house, Mark, I understand there's a ready frame project as well over here. Can we go check out that?
Let's go check that out.
All right, guys, we'll see you over at the casita. A heck of a view for your guests.
Yeah, the only worry about that is that now they're not going to want to leave. So they're going to say, I think we'll stay one more week. And you're going to go, no, somebody else is coming.
Now, this looks like traditional framing, though. This isn't quite as special as the other house. What was the change for you, Mark?
Yeah, it's a great question. You know, what I wanted to do is demonstrate that there's a lot of technologies, as you know. There's so many different ways for us to build high-performance enclosures, right? So this one, I wanted to show a little more conventional method and experiment with a few things. You know, I've got flame block because of my concerns about desert conditions and fire. We used a radiant barrier tech shield to make sure that we could look at how that's used in hot climates where they're putting ductwork and mechanicals in the attic, which we're not going to let happen.
No, I don't know. I don't know what flame block is, though. What is this?
That's a really good. It's a really good point. You know what it is? It's a special coated OSB. And so the coating has a flame-resistant layer that gives it about a 30-minute level instead of using gypsum. So in multifamily and now in some residential, when the lot lines are close, you know, they always have to use OSB, a layer of gypsum, and the other units, OSB and a layer of gypsum. So multiple rackings, they have to put up the scaffolding a couple times. Now with one layer, the framer puts it on conventionally. You can put it either face to the inside in multifamily, so the competing units, the individual units, would have a layer of flame block on each side, giving them a 1 hour instead of trying to put gyp in between them. So I did this on this side, and I've also got the flame block on the other side. So desert fire might come in and prevent it from getting to the desert.
I love it.
Well, it's a structural integrity too, which is nice about the flame block. It's already built in.
It's already built
Yeah, and it just nails on like a normal product.
Mm-hmm.
Now, Brad, I see a couple of pieces here that are labeled with an inkjet. Jack stud, header over here. Is this a ready frame building?
It is ready frame. This is our first one, so we were super excited about that, you know, with Mark and Builders First Source that worked with us on this. So this is our first ready frame.
And what did your framers think about it?
Yeah, it's just like anything, right? They have a little trepidation. You know, the first comment was like, hey, Brad, you're killing the craft. Like, this is taking our jobs. Like, we're not going to be able to perform. Like, this is, you know, the craftsmanship side. And as Mark knows, Mark interviewed him too. It's just when you speak with them, you know, how many expert framers? We know that, you know, how many skilled tradesmen are out there coming into the industry. And now where you can actually, as Mark mentioned, you know, layout is the toughest part for a framer to be able to come in, have everything labeled, that you can give a lot of direction to the field and not have to oversee them. You know, it actually helped with the build process. I mean, this went up so fast. I mean, it was
one day.
One day.
And almost no waste. You know, that was the other thing we showed him. We said, so how many cuts did you have? And he goes, not very many.
Yeah.
And so we got done, and I think that's a pretty important part, that the waste thing is what we're all trying to manage, because it seems so wasteful already, you know. And then also just the efficiency. Sometimes we see way too many studs. So if we say just use the ones on the plan, that's enough, because the theory of when in doubt, add another stud is pretty common, right? And so this really helps people stay on plan. It's fully engineered. He had a plan set that showed where everything went. Even the headers, when he had a little blocking that went across here, he goes, I bet they didn't include that. So he goes out, there's a little bundle of these.
Is that right?
He's like,
sheathing brake blocks are included in the package. They didn't have to cut those.
You didn't have to cut them.
That's crazy.
It's really cool.
And the thing that's interesting, I mean, even if you're not going to be Mr. Sustainable, right? The economy, if you're just thinking money-wise, I mean, dumpsters now, we're dealing with this with fuel, right?
So expensive.
And clients, this is a sticking point, you know, in a cost-plus job where you have fuel charges on these dumpsters and the costs, right? And just the waste, I mean, just being wasteful. As Mark mentioned, I mean, you have a little 5-gallon bucket, if that, of waste. I mean, it's really nothing.
That's amazing.
As opposed to filling a dumpster over and over by the end of the job. So.
Yeah, and no hand-cut roof either. You've got some trusses like the rest of the house. These all came from Builders First Source.
Yeah.
Looks like they're probably engineered with cutouts that you can run ducting through there.
Yeah.
In fact,
It's all
we
pre-planned.
forgot to mention that, Mark. What are you doing for HVAC on these two houses?
Well, this one's going to be a little different. We're going to have a mini split. So we're going to do the entire unit with a mini split, just
Love
a 2-ton unit over here. And then in the main house, we're going to have a 2.5-ton stand-up furnace using RIA ductwork, which is the smaller diameter, 4-inch. And so then we'll go out to some perimeter diffusers, and it's going to reach out, and we've got 3 zones. So that we'll be able to close that off when needed. So
you said that house is 2.5 tons?
Yeah,
And
over 3,000 square feet.
And I was going to say, so we're like 12 or 1,300 square feet per ton?
right.
In the desert where it's 110? Are you worried about that?
No, actually, I mean, it's funny because when you see that design, I mean, typically when you think about most mechanical design, they're trying to design 400 square feet a ton. I mean, we're 3 times that. You're essentially over 1,200. And this is way better, but it all goes to all the little, details that we pointed out.
And that's been engineered. I think you mentioned Positive Energy, which I work with in Austin, designed that. They're doing the load calcs based on your design and your air tightness. So that's a real number. That's not just a stab in the dark guess of how it's going to be.
Yeah, they did the complete layout. What a beautiful job they were able to do. And so when you have that kind of engineering, and then he's got to count on saying, now you got to give me the structure you said, right? So then we got to go to Brad and say, now make sure that the thermal enclosure is ready for that. And there's a trust thing there all the time, right? So I'm going around caulking and sealing, remembering my HVAC depends on the air tightness, which is always kind of that nice push-pull that you know that I can trust a tight calc.
Man, guys, what an incredible project. Mark, so impressed, dude. If you guys don't know Mark, I'll put a link in the description to Construction Instruction. I've been learning from him and his colleagues for at least 20 years now. And the only reason you don't know him is because he's really focused on training guys like Brad and I, builders who are in the field. The general public isn't typically getting trained by Mark, although probably more and more these days. Go to that website that's in the link if you're interested in getting trained by Mark and his crew. And Brad, you've nailed the details, dude. Impressive. How can people find out more about this house or your company?
Yeah, so as far as the house itself, Professional Builder Magazine, that's a Desert Comfort Experience. And then for us, Instagram, all of our social media is AFT_construction, pretty simple. AFTconstruction.com.
And you have some YouTube videos in this house,
We
right?
do have YouTube, so make sure to subscribe to AFT Construction on YouTube.
Let's see if we can triple or quadruple his YouTube subscriber count, guys. Go over up to the link in the description to A Finer Touch. No, it's AFT Construction.
Yeah, it's A Finer Touch Construction, but we go by AFT just for
AFT.
simple, on all of them. But yeah, we're doing a series on the net zero. And to Matt's point about Mark, I mean, Mark not only has trained us, but we actually have a client right now that watches all of Mark's stuff, that knows Mark, that wanted to meet Mark and wants to meet you too, Matt, that's
awesome.
Really involved, and we're seeing clients involved in that, and that's all through YouTube and through what we're doing here. So.
That's pretty cool. Guys, thanks for joining me for this trip to Phoenix. If you're ever building in Phoenix, make sure you call Brad and his company. Incredible job. If you're not currently a subscriber, hit that subscribe button. We've got new content here every Tuesday and every Friday. Follow me on Twitter and Instagram, otherwise we'll see you next time on The Build Show.